we have an equation, and then looks like you have balanced it. Let me check the balance equation. We have 2 here, so 4 carbon, 4 hydrogen, so 2 water, and then a total of 4, 2 is 8, and then 10 oxygen, so 5 O2. Yeah, okay. So they're asking how many grams of water can be formed if we have 113 gram of acetylene is burned. So we're gonna start out with so 113 gram of acetylene, which is C2H2. And again, the first thing we have to do for this problem is converting to moles. So moles should be on top and gram will be on the bottom.
Oh, okay.
And then we want to find the molar mass of C2H2, because molar mass will help us to convert from grams to moles or vice versa. So we have here is 2 of carbon, which is 12.01 gram per mole each, plus 2 hydrogen, which is 1.01 gram per mole. These numbers, you can look it up from the periodic table. So that one would give us, let's see, 2 times 12.01 plus 2 times 1.01. That is 26.04 gram per mole. So it means that for every 1 mole, we have 26.04 gram here. So we can see that the gram and the gram is canceled. So now we have left with moles. So now when we have moles, we can easily convert it from one compound to another using the balance equation. And we are interested in water. So water would be on top. And we started out from C2H2. So C2H2 will be on the bottom. And then if you look at the balance equation, we can see that 2 moles of water is formed for every 2 moles of C2H2 because of the balance equation. So 2 here and 2 here. So we can see that the C2H2 is canceled. So now we have moles of H2O. And moles of H2O, we are interested in the grams. So converting from moles to gram, we use another molar mass. But because now we are in water, so we have to do grams of water per mole of water. So molar mass of water is 2, and every hydrogen is 1.1 gram per mole. And then 1 oxygen, and oxygen is 16 gram per mole. So that one would give us 18.02 gram per mole. So that means that there's 18.02 gram for every 1 mole. So mole and moles is canceled out, leaving us with gram of H2O. So we just carry out the math. So 113 times 2 times 18.02 divided by 26.4 and divided by 2. And that would give us 78.20 gram of H2O. Does that make sense?
A little bit, but I think I'm just confused on the setup. Like, how do we know what to plug in for every problem, I guess?
Yeah, so we usually started out with the given, like 113 gram of acetylene. So that is the given. So we will start out by that. And this problem involving like the conversion from one compound to another. And usually when problem involving the conversion between one to another, then we would have to use the moles, because the balance equation is only good using moles. So that's why you have to do the second steps right here. The second steps right here to convert from gram to moles.
Okay.
And then when we have the moles of the original, we will use the balance equation to convert from the original to the unknown. But then the values that we received is the moles of the unknown, not the mass of the unknown. So we would have to do the last steps to convert from the moles to mass using the molar mass.
Oh, okay.
Does that make sense?
Kind of. I'll get it.
Yeah. So let's see here. So we started out as grams of original. Because the problem involves. Oh, sorry, you can't see.
The 113 grams.
Yeah.
Okay.
And it didn't update the thing. Just give it a second. I wrote something, but it doesn't show up.
Are these steps pretty much the given when we're working out problems like this?
It would be similar for these type of problem. Like if you're given a mass of something, and then they're asking for the mass of another, on the same balance equation, then yes, you just have to convert from mass to moles, and then moles to another moles using the balance equation. Oh, here. So you can see that we are given the grams of the original. So we would have to convert that to mole of original. And then using molar mass. And then from moles of original, we can convert to moles of the to be determined compound.
Of the
this case,
H2O.
like water. Yeah.
Okay.
And then we do that by balance equation.
Okay. I think I understand what you're saying.
And then from moles of to be determined, we can find the gram of to be determined by using another molar mass.
Okay.
It might be slightly different depending on what they are giving you or what they are looking for. But these are the basic steps to that involve stoichiometry and balance equation problems.
Oh, okay.
Okie dokie.
So moles is very important. Like even if you don't know what to do when you go into a problem, just find moles. That would probably give you some
be the first step to help us guide us through the rest of the steps, because I understood how you did everything else. I just didn't know how to begin it. But if you're saying if our given is 113 grams of the, I guess, what do you call that, the compound? Or
of C2H2.
Yeah, so then we're trying to find the moles from that information. If I'm on the right track of thinking it.
Yeah.
Okay. And then for everything else, we always have to find out how many moles, because you have like the molar mass of C2H2.
Right.
And you went 2 times the mass, which is, we find that on the periodic table. Okay. I know I'm probably repeating everything what you're saying. Okay. Like Liz, I think I just need to work out these a little bit better to understand it.
Yeah, so it takes a little practice to get used to the problems. So just try some more problems, and if you have questions, just let me know, okay?
Perfect.
Okay, thank you.
Thank you.